Guys, welcome to this video. In today's video, we're talking about partial fractions. Now let's go to a concept we are all familiar with. Let's say we add 3 over x plus 1 plus 5 over x plus 2. Let's say we are adding these two fractions. Now, taking the LCM, we'll have x plus 1 and x plus 2. So x plus 1, x plus 2 goes into x plus 1. We'll be having x plus 2. So x plus 2 times 3 is 3 into x plus 2. The denominator goes into x plus 1. We'll be left with x plus 1. So we'll have 5 into x plus 1. So simplifying, 3 times x will have 3x plus 3 times 2 we have 6 plus 5 times x we have 5x plus 5 times 1 we have 5 all over x plus 1 x plus 2. Now collecting like terms, 3x plus 5x we are having 8x, 6 plus 5 we are having 11 all over x plus 1 x plus 2. Now this is a complete fraction. It is not broken down anymore. Now in partial fractions, what we are going to be doing is that we are going to be converting this complete fraction back to this broken fraction. So that is what we are just going to be doing in partial fractions. Some ways of solving partial fractions. The first one is distinct linear factor in the denominator. So what do we mean by distinct factor in the denominator? When a function is linear, we say the highest power of the variable is 1. And let's say we have x plus 2, for instance. You can say that the highest power of x is 1. So this is a linear factor. And it is distinct because it is not raised to power something. That is, this linear factor is not repeating itself. It's not raised to power something like 2 or 3. So that is why it is distinct and linear. So when solving for distinct linear factor in the denominator, here is what we are going to do. So let's look at this example. Let's say we have 2x plus 7 all over x plus 1 x plus 2. Now we want to convert this to a partial fraction. For us to convert this, we are going to be having a to be a constant for one of the partial fraction all over one of those linear factors, which is x plus 1 plus the second fraction, which is b all over x plus 2. Now we can also add more fractions, but the reason why we stopped is because of the factor. We have only two factors, two linear factors. If it's that we had three linear factors, we can still add plus c all over the other factor. So now the next thing we are going to do is that we'll look for the LCM of these fractions. So the LCM of x plus 1 x plus 2 is x plus 1 x plus 2. So x plus 1 x plus 2 goes into x plus 1. We left with x plus 2. So a times x plus 2, we have a into x plus 2 plus x plus 1 x plus 2 goes into x plus 2. We left x plus 1. X plus 1 times b, we have b into x plus 1. But here we still have the same, still going to write the same thing, 2x plus 7 all over x plus 1 x plus 2 equal to this. Now if you watch, since there is an equation sign, this one can go, this one can go. So we'll be left with 2x plus 7 is equal to a into x plus 2 plus b into x plus 1. Now let's simplify this part. So 2x plus 7 is equal to a times x, we have ax, plus 2 times a, we have 2a, plus b times x, we have bx, plus b times 1, we have b. Now at this point, we can use, there are two methods we can apply. We can either apply the cover up rule or the comparison method. Now in this class, we are going to be applying the comparison method. In the comparison method, we are going to compare the coefficient of x in the right hand side with the coefficient of x in the left hand side. And we compare the constant in the left hand side with the constant in the right hand side. So we say using comparison. So we have 2x plus 7 is equal to, now bringing the coefficient of x, we have ax plus bx plus 2 plus 2a plus b. Now we have 2x plus 7 is equal to, now let's bring out the coefficient of x. We have a plus b into x plus 2a plus b. Now if we compare the coefficient of x in the left hand side and right hand side, we will see that a plus b is equal to 2 and 2a plus b is equal to 7. So you can see that this is now a simultaneous equation. So you can call this equation 1, or you can call this equation 2. So we are going to be using elimination method to solve this. Using elimination method, we can use minus here and our b is going to cancel. So a minus 2a will be minus a is equal to 2 minus 7 is minus 5. So minus cancels minus. Our a is 5. Now putting a as 5 into equation 1, we have 5 plus b is equal to 2. So b is equal to 2 minus 5. Then b is equal to minus 3. So now we have found our value of a and our value of b. Remember, a and b are the constants. So this is a, this is b. So we are going to put it back into this fraction. So our partial fraction will be 5 over x plus 1 plus minus 3 over x plus 2. Always remember to add the value of a where a is and value of b where b is. Don't alternate them, because if you alternate them, you get the wrong values. So therefore our partial fraction for 2x plus 7 all over x plus 1 x plus 2 is equal to 5 over x plus 1 minus 3 over x plus 2. So this is our partial fraction. So that's the final answer.